Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is C++ objects. Before proceeding, make sure that you have already watched these other videos first. When an object's lifetime ends, it gets destroyed. That is true the same for if it is an object variable that goes out of scope, or when we do delete on a dynamically allocated object. When a C++ object is being destroyed, it does a special action immediately before giving its memory back to the computer system. That special action is implemented by another function called its destructor. Notice how a destructor is written much like a constructor, with the addition of a tilde character. A destructor never has a return type, and it never accepts any parameters. You should think of a constructor and a destructor as partners. A destructor's job is often to undo any action that occurred in the corresponding constructor. A class can derive from another class. In this example, the dog class is called the derived class, and the animal class is called the base class. Even though the dog class didn't itself define the age data member, every dog object will inherit that. This means when memory is being created for a dog object, it will be given enough space for its own data members plus all those members that it inherits from the animal class. We also inherit the ability to call member functions like getOlder. In C++, a class could inherit from multiple base classes. However, doing so is often discouraged as it can introduce complications. Good object-oriented design uses derivation when there is a logical is-a relationship between two concepts. In this case, a dog is a animal, so it makes sense to program this way. A cat also is a animal, so we can also derive a cat class from the same animal class. This leads towards a very interesting programming technique called polymorphism. Notice that this main function creates a dog object, but then instead of continuing to use that dog pointer variable, it starts using an animal pointer variable. That is perfectly valid because we've established that a dog is an animal. The animal pointer can point to that same dog object in memory. When we are programming this visitZoo function, we know that we are being given an animal pointer as input. But inside our implementation of visitZoo, that portion of source code doesn't know that animal pointer has been pointing at a dog object. As far as that visitZoo code knows, its parameter might have been pointing at a cat object instead. In fact, it's even possible that its client might have only created an animal object that wasn't either a dog nor a cat. So, visitZoo can call getOlder, but it cannot call wagtail. Things get even more interesting if each of these classes implements a function that has the same function name for each. When visitZoo calls makeNoise, it outputs silence because the type of the pointer variable is an animal pointer. But by marking the function as virtual, then visitZoo doesn't only consider the type of the pointer variable. Instead, At runtime, it polymorphically considers the type of the object that is being pointed to. As a result, a bark is outputted. Sometimes we want our base animal class to have its own implementation for functions like make noise. Some other times, the base class doesn't need its own implementations, and the class exists only to serve as the common denominator between cats and dogs. In that case, the virtual function can be written as a pure virtual function. Now, because this animal class contains a pure virtual function, you may not create any animal object. You can only create dog or cat objects.